Hello everyone, welcome back to Joho stream. I hope you all are doing well. Today we are going to learn an important topic from data structures, which is binary tree array representation. This lesson is very important for exam interviews and also to clearly understand how binary trees are work internally. Don't worry if you are new to this topic, I will explain everything slowly and using very simple English. Let's start. First, let me explain what a binary tree is. A binary tree is a tree data structure where each node can have most two children. One is called the left child and another one is right child. The top node of the tree is called the root. Any node that has children is called the parent. A node connected below the parent is called a child. And a node that has no children, that's called the node. As you can see, this is a simple binary tree. There is a node A at the top. A has two children, B on the left and C on the right. So the node B again has two children, D on the left and the E on the right. This is simple binary tree, right? Normally, binary trees are implemented using linked list, but in some situations, we can also represent a binary tree using an array. This method is called binary tree array representation. Now, let's understand the concept of representing a binary tree using an array. In array representation, we store the tree nodes level by level. From left to right, usually we start storing the root at index 1 of the array. So from our example tree, node A is stored at index 1, node B is stored at index 2, node C is stored at index 3, and D is stored at index 4, E is stored at index 5. So the array looks like this. At index 1 we have A, and at index 2 we have B, and index 3 we have C, 4 we have the D, 5 have. Now comes the most important part of this lesson. This is the index relationship. Using index values, we can easily find the parents, left child and the right child of any node. Let's assume a node is stored at index I. To find the parent of that node, we divide the index by 2. So parent index is I divided by 2. To find the left child of the node, we multiply the index by 2. So left child index is 2 multiplied by I. To find the right child of a node, we multiply the index by 2 and add 1. So right child index is 2 multiplied by I plus 1. Now let's understand this using our example. Node B is at index 2. To find the parent of B, we can divide 2 by 2, that gives 1. So the parent of B is at index 1, which is A. To find the left child of B, we do 2 multiplied by 2, that gives 4. So left child is at index 4, which is D. To find the right child of B, we do 2 multiplied by 2 and plus 1, that gives 5. So right child is at index 5, which is E. Now let's check node C. Node C is at index 3. Parent of C is 3 divided by 2, that gives 1. So parent is A. Left child of C would be at index 6 and the right child would be at index 7. But these indexes do not exist, so C has no children. This is how we find relationship without using any pointers, only using index calculations. Now let's take another example. Imagine a binary tree with values 10 as the root, 20 as the left child, 30 as the right child, 40 and 50 as the children of 20. When we store this tree in an array, 10 goes to index 1, 20 to 2, 30 to index 3, 40 to index 4, and 50 to index 5. Again, using the same formulas, we can find the parent and children very easily. This is why array representation is simple and very fast. Now, let's talk about the advantages of the array representation. The first advantage is fast access. We can directly access any node using this index. The second advantage is simplicity. There's no need to pointers or complex structures. Third one is that works well and the complete binary trees. The fourth one is that this method is used for the binary heaps and which are very important method in data structure. Now let's talk about the limitations. If the binary is not complete, many array positions will be empty. This causes memory wastage. Another limitation is fixed size. Once the array is created, increasing its size is difficult. Also, inserting and deleting nodes is not easy compared to linked list representation. Because of these reasons, array representation is mainly used when the tree structure is complete and fixed. Now, let me explain the code which is written by Java. Here, I have created an integer array called tree. This array is used to store the binary tree. I have also created a variable called size. This variable keeps track of how many nodes are in the tree. Now looks at the insert method. When we insert a value, first we increase the size by 1. Then we store the value in the array at the index. This means the nodes added level by level from the left to right. Now looks at the display method. This method prints all the values in the array from index 1 to the last index. This shows how the tree is stored in the array. Now let me explain how we find the parent. In the parent method, if the index is 1, then the node is the root and it has no parent. If the index is not 1, we divide the index by 2 and get the parent index, and then we print the value of at that index. Now let me explain the left child method. So to find the left child, we multiply the index by 2. If that index is within the size of the tree, then the left child exists, and we print its value. If the value index is greater than the size, then the left child does not exist. Now let me explain the right child method. So to find the right child, we can multiply the index by 2 and add 1. If that index is within the size of the tree, then the right child exists and we print its value. So if the index is greater than the size, then the right child not be exists, right? So then now let us look at the main method. Here we have created some object of the binary tree array class. Then we insert value 10, 20, 30, 40 and 50 into the binary tree. After that we display the tree. So then we check the parent, left child and the right child of the node at index 2 from output. So we can clearly see how the relationship works using index calculations. This is the main idea of binary tree array representation. So to summarize this lesson, a binary tree can be represented using an array. The root is stored at index 1, and the parent, left child and the right child can be found using simple formulas. Array representation is fast and simple, but not suitable for all types of trees. I hope you understood this lesson clearly. If this video helped you, please like the video, share with your friends and subscribe to the Joho stream. More data structure lessons will be coming soon, and thank you for watching. See you in next video.